All right. Following up the in-class lecture, as I said, I was delayed in some phase shifted from my presentations, and rather than continuing the spillover of lectures from one day to the next, I'm going to wrap this up in Panopto. So, for those who have not yet used Panopto, it is a YouTube-like video service that's integrated into Elms. You could watch it multiple times. You could increase the speed if you wanted to go faster. You can slow it down if you want it slower. You can review it as many times as you want. So that's that. So last time, well, rather when I left off earlier today, I had talked about the initial discoveries of dinosaur fossils recognized as such in North America. And Joseph Leidy, who was one of the most important figures in the mid part of the 19th century in paleontology in North America, who identified the teeth of Iguanodon and Megalosaurus-like dinosaurs from the American West. And as I finished by saying, his next major sets of discovery were from far off New Jersey, actually from the New Jersey suburbs of Philadelphia, Haddonfield in particular. And the specimens found there were found not as people exploring through, the wilderness or whatever, but as they were digging for the basements and foundations of new building complexes. And they came across the bones of a very large animal of some sort. But among the bones, here you see some of the limb bones. Among the bones that they discovered were fragments of the jaw that included teeth. Teeth very similar to those of Iguanodon and even more similar to some of the teeth that Leidy had described from the American West. Well, this was clearly a new type of animal, and so he gave it a new name. He called it Hadrosaurus, the heavy lizard. Named this in 1858. So just 4 years after the Crystal Palace the Crystal Palace exhibition models went on display. And in fact, Leidy showed that the teeth and what bones overlapped between this animal and Iguanodon were extremely similar, but there were more bones for Hadrosaurus. Hadrosaurus's hind limbs were much more powerfully developed than its forelimbs, and he suggested it was a bipedal animal, that is, it walked on its hind legs, and by inference that Iguanodon may have as well. Now, he didn't have a complete skull, so he restored it as sort of an iguana-like form. Subsequently, however, we discovered that this is a representative of a group we call the duckbills, which have a very much longer snout and rounded bill at the end. Now, somewhat later, in the 1870s, one of Leidy's disciples or students, Edward Drinker Cope, who all worked out of the same area, the Philadelphia area, also described specimens from New Jersey, from the town of New Egypt, not terribly far from where the Hadrosaurus specimens were found. And these included a claw and finger bone, which he interpreted as a toe bone to begin with, but also the upper arm bones, the humeri, these bones, as well as some of the leg bones. So here is the shin of the same animal. And just to back up, so this is the same scale bar I was using when I photographed this. So those are the upper arm bones, and then this is the shin, suggesting that this animal too had much smaller forelimbs than hind limbs. So this was a restoration of the animal that he found. The elements of the jaw that he discovered showed that it had teeth very similar to Megalosaurus. And so if this was a bipedal dinosaur, a two-legged dinosaur, and was related to Megalosaurus, that led to the inference that Megalosaurus itself was also a two-legged bipedal animal. Now, Edward Drinker Cope named this animal Laelaps. Sorry, I said 1870s. It's actually 1860s. 1860s that he discovered and named this animal. However, the name Laelaps was already preoccupied. That was already being used for an arthropod, for a bug. So a colleague of Leidy and Cope renamed this dinosaur and gave it the name Dryptosaurus, or wounding lizard, which is the name it goes by today. And here we see the mounted skeleton, with much of it restored, of Hadrosaurus, and next to it an attempt to do a mounted skeleton of Dryptosaurus. Now you see this very little known of Dryptosaurus, and they're doing some mirror imaging to, where their bone is known from the left side and not the right. They make a duplicate of it. But the idea that dinosaurs, or at least some of them, were bipedal animals built entirely unlike modern creatures. Now, down here is a modern restoration of where the bones of Hadrosaurus go. And we now know, although it probably could walk on its hind legs occasionally, it probably was mostly quadrupedal. But still, the idea of bipedal dinosaurs was mind-boggling, because compared to the way that Iguanodon and Megalosaurus and Hylaeosaurus were restored, they're sort of a combination elephant and bear and lizard. And now we have the new view of dinosaurs. Well, new for the 1860s. Here's this rather emaciated Dryptosaurus attacking a herd of Hadrosaurus. And what's really amazing, this is the exact same artist who did the Crystal Palace models. This is Benjamin Waterhouse Hawkins. But because there was newer information, he was able to update what the dinosaurs looked like. Now, of course, we don't think these dinosaurs looked quite like this either. We have even more information to fill in the gaps. But it was the best information they had at the time. So this is a modern interpretation of the skeleton of Hadrosaurus. If you go to the Academy of Natural Sciences in Philadelphia, that's where this specimen is on display. And over here, this is a restoration of a pair of fighting Dryptosaurus. And it turns out that the big toe claw, as Cope originally thought, was actually a thumb claw. Dryptosaurus is a cousin of Tyrannosaurus. It's from an eastern North American group of tyrannosaurs. And this particular mounted skeleton, which is on display at the New Jersey State Museum in Trenton, this is actually based off of art from the end of the 19th century, and I'll show you that painting later on. Now, Cope is most famous for his rivalry. Cope was one of the leading paleontologists of the late 1800s in North America, and leading with, alongside his great rival, this guy, Othniel Charles Marsh of Yale University. One of the first American paleontologists to go through a rigorous, modern style education. He went to Germany to study. Actually, was in Great Britain, I think, for a while to study, and was a professor of paleontology at the Department of Geology at Yale University. Now, at first, Cope and Marsh were colleagues, and they were collegial. That is, they were friends with each other. But because they both had pretty big egos, and neither of them were necessarily that good at dealing with other human beings, they eventually became bitter rivals, and their rivalry had great benefit but also great detriment to paleontology. Now, a famous story involves how Cope had discovered remains of a marine reptile related to Plesiosaurus in Kansas. And he gave it the name Elasmosaurus, and he interpreted it as having a relatively short neck, longish, but relatively short neck, and a very long tail. Now, he had described this animal in a publication, and Leidy looked at it and said, "You've got the head on the wrong end. You can look at vertebrae, and you can look at which direction points forward and which direction points backwards," and he had put the tail on the butt. But Leidy apparently was pretty cool about it when talking with Cope, and tried not to make a big deal about it. Marsh, not so much. He had seen a colleague and potential rival who had made a great blunder, so Marsh made a big stink about the fact that Cope had the head on the wrong end of Elasmosaurus. This is what the actual animal looked like. And because he did so in a less than collegial fashion, they became extreme rivals. And their rivalry manifested as what's called the Bone War. So Marsh versus Cope, the battleground for the war would be twofold. One would be discoveries in the American West. As it was opening up to paleontology, the lands were being, acquired by European Americans. They're spreading out the Great Westward Expansion, and the railroads are now extending throughout the American West, so it's easier to bring material back. And the other place it was fought was in the realm of publications. So what would happen is Marsh and Cope would go out, or more often send teams out. So here's Marsh actually going out with a bunch of people to collect fossils with them in the American West. But sometimes they didn't even go, some years they wouldn't even go out into the fields. Cope and Marsh would stay back at New Haven, or Cope in Philadelphia, Marsh at New Haven, Connecticut, and their teams would go out and dig stuff up. They would telegraph back information about it, ship the fossils back to the east, and then Cope and Marsh would race each other to describe more and more material, to recognize new species that the other hadn't, and who was going to be the most prestigious discoverer and namer of fossils. That's what was on the line. Supposedly, these two didn't always play nice with each other. For instance, they would ally themselves with different rival Native American tribes who would then be asked to harass, not too seriously, but harass enough the other team's field crew so that their diggings might get delayed. And the other would, get more material out of the ground. Or they would send spies from one team to the other to look at what fossils were being discovered and then come back and report to Cope or to Marsh to see how the other's doing. So, yeah, that's not really nice. A side effect of it, though, of this rivalry, this competitiveness, was this provided lots of new information, lots of new fossils for fossil mammals, for marine reptiles and flying reptiles and dinosaurs and pretty much all the groups of fossil organisms that could then get described. And it turned out the North American West is one of the best places in the world to find such fossils. It has many parts of Earth history represented. It's a very rough country, and that means it's been buckling under tectonic forces that are exposing rocks from many different time units. It's relatively dry, and so it's easy to see the bones sticking out of the ground. And at this time, you now had rapid transit in the form of the rails and rapid communication in the form of telegrams, making it the perfect spot to find fossils. And it was discovered that dinosaurs didn't look like anything anyone had imagined before. No one had pictured the great frill-necked horned dinosaurs like Triceratops, or the plate-backed Stegosaurus, or finally duck-billed dinosaurs like Hadrosaurus were known in more detail. This is Edmontosaurus inectens, one of the ones for which the duck-bill group is named. And you could see that what we call the postcranium, everything behind the neck, Leidy wasn't terribly wrong on, but the head, he had no idea what the head was actually like. And the giant long-necked sauropods like Brontosaurus and Camarasaurus and Apatosaurus and Diplodocus. No one had conceived of creatures like that. And so by the end of the 19th century, we had a far better knowledge of what dinosaur anatomy was like than we had previously. Now, the Cope versus Marsh conflict eventually got them in trouble with the law because they were, not always playing by the rules, and they were using some government money. In fact, O.C. Marsh was working for the U.S. Geological Survey, a new government institution, in the later years of his career. There were congressional meetings held about their behavior and so forth. Both of them wound up spending a lot of their own money. They sort of burned up their own fortunes trying to collect fossils. And eventually, Cope had to give or sell off his collection. Some of it went to the Academy of Natural Sciences. Much of it went to the American Museum of Natural History, which is now a newer museum in New York City, run by one of his, not official students, but a person who studied with them, who we'll encounter in a bit. O.C. Marsh, well, half his collection stayed with Yale University, and Yale's Peabody Museum remains one of the largest collections of vertebrate fossils in the world. But because he had been collecting for the federal government with the U.S. Geological Survey, after his death, representatives of the government came and said, we've been gifted this big sum of money by this guy called James Smithson from the UK, and he bequeathed it to us to build a Smithsonian institution, which they thought, okay, we'll make it into a museum, and so they took half the Yale collection, and that became the foundation of the Smithsonian's collection. So in the aftermath of the Bone War, we had a lot more knowledge of the diversity of dinosaurs, compared to those original three. And this is a modern interpretation of Megalosaurus, Iguanodon, and Hylaeosaurus. I'll talk about the new interpretation of Iguanodon in a moment. But now new types of dinosaurs being discovered, all kinds of dinosaurs and other fossil organisms throughout the American West. And so the American West, including the Canadian West, became recognized as the place to go to get dinosaur fossils. Also, Cope and especially Marsh interpreted dinosaurs as active, dynamic animals, not slow, plodding, lizard-like creatures as conceived of by, say, Mantell or Buckland. In fact, this is the painting I mentioned before of fighting Laelaps or Dryptosaurus, done by a new artist at the end of the 20th century, an artist called Knight, Charles R. Knight, who was the great paleo artist of really the beginning of the 20th century. This is one of his first works at the very end of the 19th century. And look at how dynamic these two large predatory animals are. They're fighting like tigers might or like eagles might. Also, because there were finally relatively complete fossils in terms of the skeletons of dinosaurs, it became recognized that these could be the central attractions of museums. They didn't have to be plaster models like at the Crystal Palace. You could actually mount dinosaur bones as a way of displaying them. So here was the first dinosaur skeleton mounted for the Smithsonian, and it's Triceratops, one of the discoveries of Marsh. So this was a Yale specimen that the Smithsonian acquired. Now, it's not like European paleontologists just stopped finding stuff. No, they kept on finding stuff, and some of that was really critical. For instance, the first small dinosaurs, chicken-sized or maybe small turkey-sized Compsognathus, a small predatory dinosaur. So that's its head, it's upside down on its head, the neck curled back like this, its forelimbs, its hind limbs, its tail. And because it was small enough, it was all found together on what was once a lagoon deposit. And then slightly larger, but still quite small compared to the giant dinosaurs, Hypsilophodon, a cousin of Hadrosaurus and Iguanodon. And speaking of Iguanodon, there were finally complete skeletons of Iguanodon found in a quarry in Belgium. And it was clearly not a giant iguana-like animal. It had sort of this camel or horse-like face. Its forelimbs were pretty massive, and so although it could walk bipedally, it probably was mostly a quadruped. But at the end of the 19th century, they were going to restore it as a biped. One curious thing is the discovery of what that conical bone was, and it's not a nose horn. We'll see what it is momentarily. There was enough of these complete skeletons that they could be restored into their original life position. So Dallo and other paleontologists working with these fossils from Belgium were able to restore skeletons of Iguanodon. Now, that conical bone turned out not to be a nose horn. It's actually the thumb, the fused bones of the thumb of Iguanodon. So it was not a nose horn, it was a spike thumb. So we leave the 19th century and enter the 20th century. Cope and Marsh die around the beginning, or right before the beginning of the 20th century. The original dinosaur researchers, Buckland, Owen, the Mantells, and so forth, are dead by this point. So there's a new generation around. A new generation that in some way has a lot more money because the museums are getting bigger. They're able to send expeditions out to Montana and Wyoming and Alberta and even further afield, specifically to find dinosaur skeletons. The fact that dinosaur skeletons could make an important part, a centerpiece of a museum, meant that the new millionaires that are on the rise, like Andrew Carnegie, who wanted a museum in his name, could go to his team and say, "Find me complete dinosaur skeletons." And so the new museums that are popping up, like the American Museum in New York City or the Carnegie Museum in Pittsburgh, as well as older museums like Yale and the museum in London, the museum in Paris, would send expeditions out to try to get complete dinosaur skeletons as the centerpiece for their halls. And thankfully, there were places like this spot near Shell, Wyoming, and others where there were so many dinosaur fossils that they could actually get good, complete skeletons. Now, I mentioned the American Museum of Natural History. This was built on the money of Park Avenue, so some of the wealthiest people in the world. It remains one of the largest and best funded natural history museums in the world. It's a private museum. If you've ever been to New York City, you've probably gone to it. If you've ever seen Night in the Museum, the very first movie of Night in the Museum is set here. And one of its leading authorities early on, and eventually director of the museum, was Henry Fairfield Osborn, who was a paleontologist. He had studied with Cope. He had studied actually over in the UK for a while. Had a great interest in dinosaurs, in fossil mammals, in many types of fossils. And because he himself was sort of a patrician, he was from money, he knew how to court and entice the wealthy to help fund this institution. And so they were able to have huge expeditions to all corners of the world and managed to acquire some really critical fossils. So over here, for instance, the skull of various tyrannosaurs, including Tyrannosaurus rex. In fact, Osborn himself was the guy who named Tyrannosaurus rex, as well as the first raptor skull. The upper part of it, well, it's not all complete. Parts of this were missing, and it was originally interpreted as sort of a dwarf tyrannosaur until it was recognized that the raptors looked somewhat different. Now, the American Museum didn't just work in the US and in Canada. They also went to various other parts of the world, like South America and Africa and Asia. And this age in general was an age of what people have called Imperial Paleontology, when the US and especially the European powers would go out to the far corners of the world, in the case of the European countries, to their own colonies or other European countries' colonies. Conscript large crews and dig up lots and lots and lots of fossils. Just to give you an example of some of this, in Egypt, the Royal Museum of Bavaria in Germany, sent a crew out to an oasis called Bahariya in Egypt to collect fossils. Here was the team leader, Ernst Freiherr Stromer von Reichenbach, goes by Stromer, who made his most important discovery there were the isolated bones of a very peculiar carnivorous dinosaur. Now, nothing like a complete skeleton was, or indeed has been found of this new creature that he called Spinosaurus aegyptiacus, the spine lizard of Egypt. And the skeleton what bones he found were mounted for a while in Munich back in Germany, and this was the restoration of what he interpreted Spinosaurus was like. The bones that are shown shaded had been discovered. The stuff that's in white outline was simply inferred from other carnivorous dinosaurs. Another German crew out of Berlin, out of what was then called the Humboldt Museum, it's now the Museum for Natural History in Berlin, sent expeditions to what at the time was called German East Africa, would later become Tanganyika under British rule, and then Tanzania under its own independence when it fused with other previous colonies like Zanzibar, at a place called Tendaguru Hill, so far away from the centers of power. And there they found fossils of about the same age as many of the fossils in the American West, so where Stegosaurus and Apatosaurus and Brontosaurus and Allosaurus were from, that were similar but distinct from the ones back home. And these fossils were collected by this German team and brought back to Berlin, where they are to today. And here I am looking up at the giant skeleton of Giraffatitan, the biggest of the dinosaurs they found. And here's a painting of some of the dinosaurs from that location. Now, one of the greatest, in terms of scale, expeditions of the age of Imperial Paleontology was what's called the Central Asiatic Expeditions of the American Museum of Natural History. So sent from New York, a team that operated in Western China and Mongolia. So parts of Mongolia remain, even to this day, within the boundaries of China, what's called the Inner Mongolian, or the province of Inner Mongolia, and then what's so-called Outer Mongolia is the independent nation of Mongolia, at the time under influence of China. And this wasn't just a paleontology expedition. It was a series of expeditions that was going to include every conceivable part of natural history: zoology and botany, geology, archaeology and anthropology, as well as paleontology. Osborne funded it, but he didn't go on this expedition. He instead sent this guy, Roy Chapman Andrews, who was in fact not a paleontologist by training. He was a specialist on modern whales, especially small-bodied whales of the Pacific, but was thought to be a good organizer. And so they had a combination of as you see, gasoline vehicles as well as camels. They were well armed because in some parts of China and Mongolia at the time, this was an age of the warlords, and bandits were around. And here they are looking at fossils of dinosaur eggs, one of their important discoveries there. And so here's Roy Chapman Andrews and one of their Mongolian guides, and of course, a camel. Now, the Mongolian expedition, the Great Asiatic Expedition, actually, one of the things they really wanted to find were human origins, because Osborne had this mistaken belief that human origins were going to be in Central Asia. There were a number of reasons for that. If you take another class with me, I'll go into them. He was dead wrong about that. He was not the only person, by the way, to think this. So the expedition never actually achieved what Osborne was most hoping to find, but they did find a lot of stuff in all the various disciplines they looked for. And in the case of dinosaur paleontology, this include a number of dinosaurs, including some small-bodied forms, like this critter. This is the original specimen of Velociraptor. And notice, these are 5 centimeters. 2.5 centimeters is an inch. So this scale bar is only 2 inches. This specimen is about the size of my hand. I know, I've held this specimen before. So Velociraptor is not actually a huge dinosaur. It's much smaller than they show it in Jurassic Park. Also famous, and famous at the time, Velociraptor's fame would come much later, in fact, with Jurassic Park in terms of the public. But famous even at the time were the discovery of dinosaur nests. Fragmentary dinosaur eggs had been found earlier, and it wasn't even certain they were from dinosaurs. But here were clear dinosaur nests. And the dinosaur nests also wound up being not just the claim to fame, but also the thing that brought the expeditions to an end. Because if you notice the age of these expeditions, they overlap with the beginning of the Great Depression. And with the Great Depression, of course, all sorts of institutions were losing their funding because, money was scarce. And so in order to support the museum, the AMNH had an auction, as, many institutions might do. But one of the items that they auctioned off was one of the dinosaur eggs from the expedition. And the word got back to the Chinese government. And the Chinese government said, hey, when we authorize these expeditions, you said that this was for academic purposes. We were cool with that. There's a long tradition of an interest in academics and in Chinese culture. And even though China was undergoing major transformations at this time, that was still a big thread of the society there. But they said, we always suspected that this is just another example of Western exploitation of China. Of course, if you know about Chinese history, the 50 years prior to this, up to and prior to this had been a time when a lot of the Western powers were seizing the resources of China to the detriment of that nation. And so they said, so we knew, some of us suspected that you guys were really in here just to claim our natural resources. So they shut down the expedition. And indeed, Western scientists were not allowed to work in what became the People's Republic of China until the 1980s. And the next big set of expeditions weren't until the late 1980s on the part of collaboration of people from the Chinese government and outsiders, including the AMNH, which did get back in the game in the late 80s. But in general, the Depression was the beginning of a dark age of dinosaur paleontology. So first of all, the Great Depression. A lot of money around, not a lot of resources available for something which might be seen as, fair enough, frivolous, like understanding life of the ancient past. Although, to be fair, actually some people took advantage of opportunities in the Depression. There was some of the work project money that was available, and some folks working out in the West said, well, we get a lot of crews out here, maybe they'll dig stuff for us and get paid at the same time. So there was some of that, but in general, not a lot of opportunity. And then World War II comes along, and World War II, most of the people who would have been doing field work anyway were younger men. They're going off to fight in the wars. Many parts of the world, the war is actually taking place there. That's going to slow down a lot of non-essential research. Also, even back home, this being the U.S., a lot of people don't seem to be aware of this, but during wartime, the average American citizen was under a lot of restrictions, and far more restrictive, actually, than we went through with the pandemic. You weren't allowed to just travel wherever you want. You had to have papers showing that you were allowed to travel. You had to get authorization for the petroleum if you were going to be gasoline if you're going to be traveling somewhere. You had a very limited amount and so forth. And so very little, not none, but very little paleontology, especially field work, got done, even in a place like the U.S., which was far removed from the fighting. Also, war itself causes great destruction. And of course, the worst of that is loss of life, but there's also the loss of property. And indeed, many of the important fossil collections were damaged and in some cases utterly destroyed by bombing during World War II. So although the British Museum in London itself wasn't hit, there was an impact in the street between it and the Victoria and Albert Museum. And you could still see the scorch marks or the blast marks on some of the walls there. But the museum in Bristol actually was struck and many fossils were destroyed. The museum in Munich was pulverized, and that original Spinosaurus skeleton, in fact, most of the fossils found by Stromer's team were destroyed. The museum in Berlin was hit, although many of the important specimens had been moved out of there before it was obliterated, and so on and so forth. So, yeah, part of the fact of war is that places like museums get destroyed. Also, newer generations were around, and indeed Osborne's generation itself, so the dawn of the 20th century, had differing attitudes about dinosaurs than had the previous generation. The fact that dinosaurs were popular and brought people into museums was actually held to be detrimental. It was thought, if any, I'm sure you know those kind of people. Anything that's popular, it must not actually be very good. It's too mainstream. And so dinosaurs were thought of as kid stuff. Real scientists, they thought, study fossil mammals or the ancestors of mammals or maybe marine reptiles or fish or the origin of vertebrates. Dinosaurs, no, that's silly. That's, only immature people would study them. And possibly in part as a consequence of people, or even the researchers, not being as familiar with dinosaurs as they might be, they began to be described by people like Osborne and so forth as a maladaptive side note in the history of life. The idea was that they were slow, stupid, swamp-dwelling creatures. And so these paintings Well, this painting here was by the same person who did that Dryptosaurus fighting thing. And in his later drawings, Charles R. Knight tended to show dinosaurs as plotting animals. And there's Burian in the middle of the 20th century restoring Giraffatitan as this slow-moving animal, too heavy even to walk on land. That's the interpretation. As a consequence, by the middle of the 20th century, there were actually very few dinosaur paleontologists, fewer than had been around at the dawn of the 20th century. But that shifted in the 50s and especially the 60s onward. One of the first of this new group of paleontologists was this guy, John Ostrom, who eventually wound up with Marsh's seat at Yale University, and whose research helped rethink what dinosaurs were like. And I am very proud to say I was a graduate student with him. He was my advisor on my PhD. I was one of his last students when he was a full-time faculty member back in the late 80s and earliest 90s. And so here he is with his most famous discovery about to attack him from behind. But I'll get to that in a moment. Now, Ostrom's work as a graduate student looked at the duckbill dinosaurs like Hadrosaurus and Edmontosaurus and so forth. And he showed that despite people of the early 20th century saying that these jaws were poorly adapted and only suited for eating the softest of aquatic vegetation, that in fact they were some of the most complex teeth that nature has ever evolved, some of the most durable, extremely well adapted for processing lots and lots of food. And he, in fact, said an animal that needs to process this much food in this sophisticated fashion is probably going to have a higher metabolic rate. They're not simply gulping down lots of vegetation without processing it and let it digest slowly the way a giant tortoise does. His postdoc work looked at the jaws of the horned dinosaurs, and he found something comparable. Not exactly the same. This is more shredding or shearing teeth rather than grinding teeth, but they were also well adapted for processing, in this case, tougher vegetation, but perhaps, again, indicating a more active metabolism than thought. Then after he got his job at Yale, he was part of a set of expeditions to rocks from what's called the Cloverleaf Formation, so FM is formation, which is from what we call the early Cretaceous epoch of Montana and Wyoming. It's this paler colored rocks down here. This was in between many of the classic dinosaur sites from the Jurassic with Allosaurus and Stegosaurus and Brontosaurus. And then the famous sites from the end of the Cretaceous with Tyrannosaur dinosaurs and horned dinosaurs and duckbills. And he said this was sort of a twilight zone in the history of dinosaurs and wanted to study it more. Now, American Museum researchers, including people he had studied with, had found specimens in the 1930s in the Cloverleaf, but not much work had done since. So in the 1960s, they said, we're going to go back there, we're going to start digging. And on the last day of the expedition in 64, coming back from the field, getting ready to break camp, Ostrom tripped over this. Okay, it's not this. This is my plastic copy of it, but this is a copy of that claw. It's the same claw you see right here. And it was interesting because it's the claw of a carnivorous dinosaur. They had found some herbivorous dinosaurs earlier, but boring. Okay, that's mean, but still true. They said, okay, this is cool. And they thought, oh, first, okay, it's a hand claw. There were carnivorous dinosaurs known with hand claws sort of like that. So let's mark the spot. We'll come back and see if there's more material. And they came back the next year, and there was more material, including a complete foot. And lo and behold, that was not a hand claw. It was a toe claw. And that was weird. A slashing toe claw on a retractable toe. So a toe that can curl back like the toes on a cat to keep this very big, sharp, blade-like claw off the ground so it didn't wear down. Now, they didn't just find the foot. They found most of this dinosaur, a small-bodied carnivorous dinosaur, to which Ostrom gave the name Deinonychus. terrible claws when he wrote up the description of it in 1969. If I was doing this live, I would show you my Deinonychus dance. The Deinonychus dance is not actually a dance. It's the reason that Ostrom thought this animal really showed us new information about the behavior of dinosaurs, because this claw on the foot, unless it's going around going after the ankle of other dinosaurs, wasn't very useful. It suggested that it was standing on at most 1 foot, if not 0 feet, that is, kicking up into the air and slashing or piercing into the flesh of its victims, a far more dynamic mode of attack than anyone pictured dinosaurs in the 20th century. Also, its stiffened tail suggested it was quite agile, and so a weird view of dinosaurs began to take shape. Now, you probably don't think this picture is weird. You've never lived in a world where Jurassic Park wasn't around, and so you're used to seeing raptor dinosaurs. This was radical when it came out. No one knew what the full anatomy of a raptor dinosaur was like prior to Deinonychus. The original Velociraptor skeleton was very fragmentary. But now we knew what raptor dinosaurs looked like. Active, dynamic, agile, not terribly big. And this single drawing became sort of the poster for a new view of dinosaurs. Now, this poster, by the way, or rather this picture, was done by Ostrom's undergraduate student. He was in the honors program at Yale, a guy named Robert T. Bacher, or Bob Bacher, who would go on to have his own great big career in dinosaur paleontology, which I'll get to in a moment. But before I leave Ostrom, Deinonychus was a gift that kept on giving, because not only did it show that dinosaurs, or at least some of them, were agile, fast, dynamic, he eventually realized that bone for bone, advanced carnivorous dinosaurs like Archaeopteryx and primitive birds like Archaeopteryx were extremely similar to each other. That is, Deinonychus was more similar bone for bone to Archaeopteryx than Deinonychus was to a typical meat eater like an Allosaurus or Tyrannosaurus, or than Archaeopteryx is like a modern bird like a raven or a hawk. And it revived, and Ostrom revived and modified an old idea, and that was that the origin of birds was among the dinosaurs. And indeed, that has guided a lot of the research since, as it became more and more clear. So Ostrom began to map feature after feature after feature in Deinonychus and other raptor dinosaurs, like this half-moon-shaped wrist bone present here in Deinonychus and here with a small arrow in Archaeopteryx, that demonstrated a dinosaurian origin of birds. Now, Ostrom, as the leader, and various other researchers coming up at the time, somewhat younger than him, like Jack Horner of Montana and Ostrom's former student Bob Bacher, began to lead a new age of dinosaur research. One where we were interested in the biology, the classification, and especially the behavior of dinosaurs. And we'll talk about the contributions of Horner and Bacher and many others throughout the rest of this course. In fact, this became known as the Dinosaur Renaissance, so called after this article by Bacher in the magazine Scientific American. This came out in April 75. I was a very young kid. I wasn't even 10 yet, but my mom got me a copy of this issue because it had dinosaurs in it. And this was profoundly moving for me because for the first time I had seen something about dinosaurs where I found more than just facts and, cool pictures, because this was a description of how we use fossil information to try to answer questions about dinosaurs. This is sort of my entry into a world of dinosaur science. And in general, this heralded for a broader audience a view of dinosaurs as active and dynamic and of worthy of scientific interest. So this era of the Dinosaur Renaissance is what really kicked off the research in dinosaurs. What kind of research? Well, basically what we're going to talk about for the rest of this course. And so this last slide, the sorts of things that have dominated modern dinosaur research. The evolutionary relationships among dinosaurs. That's a lot of actually what I do. an increase of our knowledge of the global dinosaur record, many new expeditions all over the world, this time not just from the West going to other parts of the world, but in collaboration with or organized by the people of those nations. A lot more interest in and scientific approaches to the behavior of dinosaurs, in part inspired by a more serious look at the behavior of modern animals. Also, our ability to resolve details inside the dinosaurs, whether that's CT scans of skulls to look at the brain structure, or microscopic analysis of the physical structure of bone, or even molecular or isotopic analysis of materials and fossils, have given us a lot of insights. Insights into things like dinosaur physiology. Newer techniques have let us look at the mechanics of dinosaurs, how they operated in the physical world. And a whole slew of different types of sciences have been used to look at the issue of dinosaur extinction, which is going to be occupy much of the last week of lectures. So basically, what is the Dinosaur Renaissance? It's the information that we're going to talk about for the rest of this course. So sorry that was basically a whole other lecture. I'll make notes for next year that's the way I've got to do it. And take care. See you in class when we pick up dinosaurs. We're going to pick up looking at the geology of paleontology. Take care.